So in this video, we are looking at solving simultaneous equations graphically. Now, the word simultaneous essentially means two things happening at the same time. So typically in this course, we are dealing with two equations that just occur, and we're trying to basically solve them simultaneously. So find a solution to both of them. Now, in a graphical context, which is what we're doing in this video, in order to solve simultaneous equations, we are just graphing the two lines and then seeing the point where they meet. Now that point will have an identical x and y value for both equations, and it's going to be a point that satisfies both equations. So I've got some steps here for you. In order to do this, you first have to draw a number line, obviously a number plane. You have to graph both of them individually, and then you read the point of intersection of the two straight lines. So there will be a point where they cross, and you are to figure out and identify what that point is, and that is your solution. For some later kind of questions, as the course gets harder, you may need to interpret the point of intersection for practical applications. We'll look at some later videos on this in terms of like the cost to, or the amount to sell to break even, for example, or other sort of real world applications of our simultaneous equations. But I've got one over here, which is just to say, we want to find the simultaneous solution of y equals x plus 3 and y equals negative 2x. So we're just going to graph both and identify the point of intersection. It's just this example for today. Now, I'm filling in my table of values. You can do this using the gradient and intercept if you'd like, but I'm just going to go over it in this way. So we have y equals to x plus 3. So each of these x values, we are going to substitute into here. So I have minus 2 plus 3, that gives us 1. We have minus 1 plus 3 gives us 2. 0 plus 3 gives us 3. And we can see the gradient, this coefficient of x, is really just 1. So it tells us that this will just go up by 1 every single time. But you can even check that by substituting in. So next one, we're going to do a similar thing. So y equals negative 2x. So we are going to just substitute these x values, these various different x values, into here. So we have minus 2 times minus 2, that gives us positive 4. Minus 2 times minus 1 gives us positive 2. Minus 2 times 0 gives us 0. Minus 2 times 1 gives us minus 2. And minus 2 times 2 gives us minus 4. So all we have to do now is we just have to graph them. So I'll do the top one in red. So when x is negative 2, y is 1. When x is negative 1, y is 2. When x is 0, y is 3. And so on, so forth. So we are going to connect up these. And we're just going to just extend the line in both directions. And then label. So this is our graph of y equals to x plus 3. All right, next one. We're looking for the line of y equals negative 2x. So when x is negative 2, y is 4. We'll do this in blue. 1, 2, 3, 4. It's going to be here. When x is negative 1, y is 2. And we can already see, now I've drawn a point on this actual line. So immediately I can see what solution I'm going to expect. But let's just draw it in regardless. And we will see that if you draw a line, where these two lines intersect is this point over here, which we'll give in just a moment. All right, once again, we'll label our line. So this is the line of y equals negative 2x. And we can clearly see our point of intersection is right here. So that's our point of intersection. Now its coordinates are negative 1 in the x and 2 in the y. So our point of intersection or the solution to the simultaneous equation is -1, 2. Or in other words, x equals -1 and y equals to 2. Now we can check this, okay? Because this is a solution to both of the equations. So x being -1, y being 2 is a solution to both. So let's just check this. So when x is -1, a solution to an equation, remember, means that it makes the left-hand side equal to the right-hand side. It makes it a true equation. So having -1 here, I have -1 and I have 2 on this side. So I will have 2 equals -1 plus 3. -1 plus 3 equals to 2. So 2 equals 2. It is a valid solution for this one. And checking the other one, when x is -1, I have -2 times -1, which will give us +2. And y is 2 on this side also. So we'll have 2 equals to 2. So when the left hand equals the right hand side, it is a solution to the simultaneous equation. And it's only a solution if it works for both. So that's a way you can check this for yourselves. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.